In this video, we're going to look at an object and understand why it needs the amount of memory it does. And to do that, we need to understand how V8 implements objects internally. So right now I'm on example.com, but it really doesn't matter what site you're on. Let's start by creating a new object in the console. So we create a new constructor for a thing, and in the constructor we want to add two properties to our thing. So thing.a equals the string a, and then thing.b is the string b. And now on the window we're just going to put a new one thing is a new thing. So how big do you think a thing object is in memory? In this case we have two properties, a and b. So we need to store references to the two strings that are stored in these two properties. On a 64-bit system, one reference at one location in memory is going to take up 64 bits. And one byte consists of 8 bits. So one reference is going to consume 8 bytes of memory. So given that we have two references that we need to store to the two strings on our properties, a naive assumption would be that the thing that we just created is going to take up 16 bytes of memory. So let's see in the Profiles tab how much memory the thing object actually takes. If you're using a newer version of Chrome, you might not have a Profiles tab, but instead you have something called memory. But you can create a heap snapshot, which just shows you all the objects that are in memory and how much memory is used by them. So if I do that, I can see the constructor that was used to create certain objects, and then the shadow size, which is what I'm interested in at the moment. If I filter this down to just things, you can see the thing here, and actually it takes up 104 bytes. So that's a lot more memory than the 16 bytes that I would have normally expected. And the main reason for that is that because JavaScript is a dynamic language, when you create an object, Chrome doesn't really know how much memory it should allocate. So to deal with that, it is quite generous when it first allocates the size of an object. But as you create more thing objects, Chrome actually learns how big your object should be. So it can later on create smaller objects once it knows that the object is not going to exceed a certain size. So I think the threshold is 8 objects for this. So if I create another 7 object, I would expect the amount of memory that's used by a thing object to actually go down for each individual thing object. So create another heap snapshot and look for things. And you can see now the size is down to 40 bytes, which is much closer to the 16 byte that we originally guessed. But still, it doesn't quite match the mental model we had earlier. If you look at this, we can actually see what is stored inside this object. So it's quite obvious that we have two references to strings that we need to store because we have those properties actually explicitly stored on this object. So that accounts for 16 out of 40 bytes. But then there's another thing, which is a map. A map is the internal name that V8 uses for hidden classes. And if you haven't heard of hidden classes before, it's something you might want to Google and learn more about. But the key idea is that rather than being completely just like a hash table or dictionary, objects in V8 are actually represented using a certain type system. And you can think of them as a class basically. So for example, this class that's stored at index 100789 is always going to have, I think, descriptors a and b. So this means this object has a certain shape. And because all the others were created in the same way and have the same properties, these object also has the same hidden class. As you can see here, it's the same object ID. So that also kind of makes sense given the way V8 works internally. Proto, I think it is pretty meaningless actually. So this does not use up any extra memory. And I think it was added originally because the hidden class wasn't shown, and it would have been confusing to not have that reference. But now that the hidden class is actually shown inside the heap snapshot, I don't think there's any use for proto anymore, because if you go into the hidden class, you can find the prototype in there already. So we have 24 bytes explained, 16 for the two references to A and B, and then 8 for the hidden class. But what happens to the remaining 16 bytes? There are two additional properties on each of these objects. The first is called extra properties, and it's used to allow objects to grow after Chrome has determined that a thing object should take 40 bytes, because you're still able to create additional properties on this object. So to show this, if I edit window to one thing and add a C property and assign the value C, and then recreate my heap snapshot, what I'm going to get is that this extra property becomes visible. This extra property called properties. V8 doesn't have enough space to just add more and more properties to this object. But as your object grows, as your thing object grows, it doesn't actually change the size of the thing object itself. And instead what happens is that all additional properties are stored in this extra properties object. And that is what takes up another 8 bytes in each of these thing objects. And then finally, there's also a special rule for numeric indices. So if I have, I don't know, like a 3. Actually, I think I want to do this instead. Actually, it's better to do this because 3 is not going to show up as a reference in the inspector. So I take another heap snapshot and do thing. And you can see there's this elements property in addition to the properties. And this elements property contains all the numeric elements. So that's why our object takes 40 bytes to store. We have the elements property, we've got the hidden class, we've got the additional properties, and then we have A and B. And each of those properties is a reference that takes up 64 bits or 8 bytes. If you want to learn more about this, there's a good article about object representation in V8. And you can see that it has this representation using hidden class, extra properties, elements, and then the properties that are stored directly on the object. And map and extra properties and elements both reference other objects that store additional properties. So if you'd like to learn more about this, I'm going to put the link to this article in the description and you can read up on a few more details.